In this video, we're going to look at the proof of the summation formula that the sum as k goes from 1 to n of k cubed can be given by n times n plus 1 over 2, all of that quantity squared, or equivalently n squared times n plus 1 squared divided by 4. We're going to act very similar to example 3 in our textbook. In other words, we're first of all going to let Sn be this expression over here, n squared times n plus 1 quantity squared over 4. And I want to observe that S1, and let me clean up my notation. So I want to observe that S of 1 is going to be 1 squared times 1 plus 1 squared over 4, and that's going to be 1 times 4 over 4, which of course is a big fat 1. And it's important to note that that is indeed the sum as k goes from 1 to 1 of k cubed, because that would simply be 1 cubed, which is a 1. So our formula works when n is equal to 1. Just like in the book, we're going to observe that if we assume for a minute that if the formula works for both n and n minus 1, then what we're going to have is that Sn minus Sn minus 1 is going to be, well, first of all, it will simplify to, well, let me go ahead and write this out. If our formula works, this would be 1 cubed plus 2 cubed plus all the way down to plus n cubed minus 1 cubed plus 2 cubed. We stop at 1 before n. And so if our formula works, then Sn minus 1 would wind up being n cubed. And if our formula doesn't work, so if our formula is wrong, then Sn minus 1 would have to simplify to something other than n cubed. And so what I want to now do is I want to look at this particular algebraic thing, given that we have defined Sn by this expression. So let's now look at writing down what we need to do. Sn, by definition, is n squared times n plus 1 quantity squared over 4. So in Sn minus 1 is going to be n minus 1 quantity squared times n minus 1 plus 1 squared over 4. But that simplifies to n minus 1 squared times n squared over 4. And look at this. If I look at Sn minus 1, we're going to have n squared times n plus 1 squared over 4 minus n minus 1 squared times n squared over 4. And rather than multiplying things out, I'm going to again notice that I've got an n squared in both terms, and they're both over a 4, so I can do some factoring. Sn minus 1 can be written as n squared over 4, and when I factor out n squared over 4, I have an n plus 1 squared minus an n minus 1 squared. And let's see, what does that simplify to? Well, these are easy enough to multiply out, so I've got that n squared over 4. And when I square n plus 1 squared, I'm going to have an n squared plus 2n plus 1. Then I have that minus sign, and when I square n minus 1 squared, I get n squared minus 2n plus 1. And then I have the closing parenthesis there, and then the closing bracket for that one. So I'm now looking at n squared over 4 times. And I'm going to take care of that minus sign and distribute it out over all three of those terms. And we have n squared plus 2n plus 1 minus an n squared minus a minus 2n minus a 1. And now we go looking and we see we have a positive n squared and a negative n squared, so they're gone. We have a positive 1 and a negative 1, so they're gone. And so what we have is n squared over 4 times 4n, and that simplifies to n cubed. And so what we have is Sn minus Sn minus 1 does simplify down to n cubed, and let me correct my handwriting in that step up there. That should have said n cubed. And so what this says is that because our base step worked, and Sn minus S times n minus 1 is equal to n cubed, which is equal to the formula for add up all of the cubes up to n and then subtract off all of the cubes only going up to n minus 1. Because of those two facts, we can say that the sum as k goes from 1 to n of k cubed is indeed going to be n times n plus 1 all over 2 quantity squared, or if we simplify it, n squared times n plus 1 squared over 4.